Hi everyone, welcome to today's EU Sustainable Energy Week workshop. My name is Mark Power from Irish Manufacturing Research, and I'm also involved in the IBCOM project. So just for the first couple of minutes until all attendees join the room, if possible, if you can write in the chat function just where you're speaking from today, so what industry you're involved in, and also what your job title would be. That would be great, just so we have an idea of the types of people in the room and who we can frame our questions and answers section to. So if you can do that for the next minute or so, that would be great, and then we'll carry on with the rest of the webinar. Okay, so we'll continue with the webinar. As I said, my name is Mark Power from Irish Manufacturing Research, and today we're here for the EU Sustainable Energy Week workshop in collaboration with a couple of other projects. So today we have a esteemed line of guests who will be speaking to you. So we have from the COLLECTIEF project, we have Mohammed Zira Agiai from Norwegian University of Science and Technology, from the IBCOM project and fellow Irish Manufacturing Research colleague, Paula Lisa. From the SATO project, we'll have Professor Pedro Ferreira from the University of Lisbon. The AUTODAN project, we'll be hearing from Beatriz Fraga del Cal from IES, and also Selena Solari from RENA C. Following each presentation, we have a polls and Q&A section for the last 30 minutes of the webinar. And this will, first we will go through a poll that will be set out from Lorenzo Sibioni from R2M Solutions and IBCOM and COLLECTIEF project. So as I said, really interesting lineup today, and it'd be great to hear from all the speakers involved. So firstly, I suppose, let's talk about what is EU Sustainable Energy Week. It is an event that's currently happening this week in Brussels, the physical event. So yeah, it's the biggest annual event dedicated to renewables and efficient energy use in Europe, and comprises a series of activities aimed at building a secure and clean energy future for Europe. And it looks at bringing together public authorities, private companies, NGOs, EU project partners, researchers, consumers to promote initiatives to go green and digital for Europe's energy transition. So why we're here today is there is the physical conference, as I said, that's happening in Brussels, but there's also an initiative to have Sustainable Energy Days. So what are they? So Sustainable Energy Days are events that are taking place around the world at the moment, promoting clean energy and energy efficiency. These events have been happening in different areas of the world for the last couple of weeks. And some really interesting, some work has been done. I think there's one more week of workshops to go, but if you're looking to find out more about these workshops, I would look at the EU Sustainable Energy Places website, where there's a whole list of events that you can see what's happening in your area, or else obviously the virtual space as well. So every Sustainable Energy Day is an opportunity to inspire behavioral changes, innovations towards meeting energy and climate goals in the EU and around the world. So that's all from me from today. First, I'm going to hand you over to Mohammed Zira, who's going to bring us through the COLLECTIEF project. So Mohammed, when you can, if you can share your screen, and we'll start from there.
Thank you so much, Mark, for a nice presentation. Could you just, yeah, you made it fast. So I'm going to share my screen. It's fine?
Yeah, that's fine. Yeah,
Okay,
everything's okay.
great.
Yep, thank you.
So first of all, very welcome to this workshop. I'm Mohamed Reza Aghai. I'm project coordinator of the Collective Intelligence for Energy Flexibility, which is an EU Horizon 2020 project for enhancing energy efficiency and flexibility in existing building. So today I'm going to present the project, and at the same time I'm going to also give you a short overview about what we done so far and what was the status of the projects by M24 and the upcoming months, what we are going to do and what's left for the activities between the partners. So we are 15 partners from 6 European countries, and this project is running for 4 years, starting from the June 21, and hopefully we can wrap up the projects by middle of 25. We have 4 urban pilots in 4 countries. So here are our partners: NTNU, EM Systemers, Cyprus Institute, and NODA, Lund University, Energy at Work, Olesson Comune, CETMA, Politecnico di Milano just recently joined us around 6 months ago, and Virtual, and Geonardo, and CSTB, Tycos Group, and R2M, and then the last time. So here are our team. So including the industrial partners and academic partners. So we have a pool of experts in our consortium, and we are happy and proud of them. And the main idea of our projects is based on the smart readiness indicators, and most of you are familiar with that. This SRI is like a EU scheme and methodology, and which can measure and rate smart readiness of the buildings. And this is based on the 3 key functionalities: the energy efficiency and overall in-use performance, adapt their operation to the needs of the occupants, and adapt to the signals from the grid, like energy flexibility. So the previous projects more focus on the first 2, and the latter one on the communication with the energy suppliers was missing, and the collective tried to actually improve the communication between the suppliers and the end user and occupants in order to provide the energy flexibility for both sides. So our solution is to upgrade the smartness of the existing buildings in the higher level. So we promise at least 1 level. And we try to also control the household and appliances inside the buildings and any other energy systems inside the buildings, and in order to provide the minimum need for the data transfer and storage. So and also this is like a low cost and replicable solutions, and we use actually the available components in the markets and integrate them in order to improve the energy flexibility and energy efficiency. I would like to invite you to just watch our video, so then you can understand about the concept of the projects and the innovation of the project. So as you understood, actually, the collective projects is based on the collective intelligence, which is the distributed intelligence paradigm. So how it works? So normally we have two intelligence node. We call it cluster node and edge node. You see here. So in the cluster level, actually, we communicate the flexibility needed from the suppliers to the end user. And we able even learn in the cluster node, we able to learn actually the how and when the flexibility needed. And in the edge node, we try to control the appliances and households. And also we consider the thermal comfort and any preference from the end user. And for instance, in the maybe at morning, we able to just stand by the washing machine if the flexibility needed, and if in the afternoon maybe we can stop the charging the electric vehicle. So it depends of the preference of the end user and occupants, and at the same time depends of the flexibility needed by the grid. And of course, we have a digital dashboard and the user interface for communications. And of course, we need to provide like a signals, and this preference can be adopted here. So we have several solutions from our experts, and including the sensors. Sensors is one sensor. This can actually collect the environment data. And we have a smart plug and smart thermostat, and we can actually communicate with the appliances. And the main brain of the collective can be set up in the brick, and the brick device is the one components can actually communicate with the clusters, and at the same time control the appliances. And about the business model, so we targeted two main market. Let's say the first is about the energy community, like aggregators, and at the same time the suppliers who need the flexibility. So we can provide the market for the both end user and the suppliers in order to sell and buy the flexibility. And at the same time, we can provide the solutions for the individual buildings, and in order to control any devices on the existing buildings, and at the same time provide the flexibility for the end user and sell the flexibility. So we have 4 pilots located in 4 cities, including the 7 buildings, including residential buildings and non-residential buildings in Ålesund in Norway, located in middle of Norway. And we have one living lab in Grenoble in France. We have 3 main tower in Milano, including several pilots. And we have 3 pilots buildings in Cyprus, in Nicosia, in the University of Cyprus. Here are our work packages. So we have 7 work packages, including the project management and coordinations. So also about the benefits and what we promise to you, we are going to actually upgrade the smartness level of the existing buildings, and at least 16% on average reduce the primary energy use. And we assess this in some of our pilots. And we promise to actually, do the saving of the cost of the energy, annual cost saving for around €3 per square meters, and 15% increase user satisfaction, and increase of the demand flexibility up to 24%. And here are actually expected impacts. So at the moment, in second year, actually, we focus mostly on the installation of the monitoring stuff and the systems in order to monitor the performance. And now we are in the phase of the baseline. And in the last year, or let's say in the last phase of the projects, we focus on the impact assessment. So we are going to consider several aspects, including the upgrading existing building to higher level, as I said, and reduction energy consumption and the cost, and primary energy saving. And of course, we want to consider the sustainable energy and improve the user satisfaction and increase the flexibility, which is the main target of the project. So we already passed the second year, so we are in the third year. So we have performed several activities in the second year, especially, and we deliver many deliverables, up to 25 deliverables so far. Is a bit much, but we fortunately were on time and we submitted. In this year also we have many milestones and deliverables. So here are some pictures about the installation in the pilot site, including the sensors and spark plugs, and of course the POE. So we provided some questionnaires for the end user and occupants for our survey about the thermal comfort. And here is a short pilot interview. I think still we have a time, so I would invite you to watch it to see about their willingness to collaborate with us.
I'm sorry, Mohammed, the sound isn't coming through from the video. So maybe
Okay, so I can skip it,
yeah,
but you
maybe
can find
first
it.
yeah, or if you want, you could add the link to it afterwards
Absolutely.
into the chat so
Sure.
people can find it afterwards. So yeah, thank you.
Yes.
Sorry. Okay, thank you.
So let's continue. Sure. Yeah. So we developed the user interface and digital dashboard in the second year of the project, and we already actually had a successful small scale demonstration in one living lab in Grenoble, and we tested the reinforced learning demand side management in the one living lab, and it was very successful. And very soon we are planning to actually start the larger scale demonstration in the pilot site. So we already plan for starting in the Norwegian pilots. Then we will start with the Cyprus suppression pilots and then Italian pilots. So here is the third collective general assembly meeting in Olesson last year. It was very great to visit for the first time our colleagues there. And just recently we had a fifth collective general assembly in Grenoble in France, and it was very, very productive. Thanks a lot. And if you are interested in these projects and if you have any questions or would like to have a collaboration with us, just reach out to me. And through our webpage, you can find more information about projects. And I will also share this link. Sorry for it's has a problem about the sound. So that's great. And thanks a lot and enjoy the rest of the workshop.
Thanks, Mohammed. That's a very good presentation, very informative, and looks like a very exciting project. So we will definitely keep an eye on that for sure. So next, I'd like to welcome Paula Lisa from Iris Manufacturing Research, who's going to take us through the iBecome project.
Hello, hi Mark, thank you very much. Let me just share my screen. Give me a second. Can you please just confirm that you can see it?
Yes, working fine. If you can just go into presenter mode, Paolo. Yeah, that's great. Thank you.
Okay, thank you. Well, welcome. Hi, everyone. Thank you very much for joining us today for this workshop. My name is Paulo Lisa from the Irish Manufacturing Research, and I'll be talking about iBecome, which is the intelligent building asset control for comfort, energy, and flexibility optimization. The agenda for today is the reshaping Europe's buildings energy performance with iBecome, where I'm going to give you an introduction about what is iBecome and what it is aiming to do. Next, I'll be exploring the iBecome virtual building management system and services. And finally, I will just show you some of the IBCAM key components. So IBCAM wants to reduce bills in a facility through energy savings and demand response, while improving occupant well-being through optimizing comfort by leveraging IoT data analytics and the efficiency control of a building, and while enabling additional services such as EV charging and optimization. And our motivation is that we spend 90% of our time inside a building, and more than 40% of energy and 36% of emissions are attributed to buildings. And roughly 75% of our existing EU building stock is energy inefficient, with poor indoor health and well-being, lack of intelligence and interconnectivity in existing buildings. And now we have the Internet of Things and big data evolution that can help us to tackle the challenge above. Our ambition is to reduce the energy use and energy bills in a facility by 15%, and reduce comfort complaints by 20% and improve indoor air quality by 10%. Improve the smart readiness of buildings by 10%. Track, prevent, and reduce equipment and operational faults by 20%. Improve wellness by 20%. And generate revenue by energy savings to invest in further energy conservation measures. So moving to the IBCAM virtual building management system, we all starts with data. Data is the core of our solution, most of the recent solutions that involve smart buildings. And we use it for monitoring and also for on-site automated and control. With this data, we can do some science and create some forecasting toolbox, and also use it for analytics, insights, and advisory control. Sorry. And with this data and these tools, we can provide services such as retrofit, design and implementation, fault detection, diagnosis and maintenance, optimization, that can be energy or comfort, and welfare and commuting management. Also, as a scope of IBCAM, all the ICT infrastructure is being developed to enable all the services and data collection. Well, IBCAM is composed of 4 demonstration sites. The first one is Country Crest in Ireland, which is a food processing facility. The second one is Helix Building in Glasgow, Scotland, which is an office. The third one is in Italy, which is a care home. And the fourth and last one is a business center in France called World Trade Center in Grenoble. So we have a different mix of utilization of buildings. So this is also enable us to test different types of use case and else. Just some words about the IBCAM status to date. So we have completed all the preliminary studies, reports, analysis, framework review, and all the deliverables are available on our website. So if you want to learn more about IBCAM and its components, you can just go there and download this. You can find also good material about how IBCAM is aiming to tackle like this challenge. And in IBCAM, we have completed the 3rd year. We are now in the 4th year, and all the installations completed, very much in all the pilots. And now we are in the stage of deploying services, that you'll be talking in a minute in more depth. So the virtual building management system service that IBCAM is going to provide is composed of 2 parts. The first one is the core solution, which will provide the energy and comfort optimization, which can be the monitoring of CO2, of the temperature, of humidity. It can also bring automated control of HVAC systems. The second one is measurement and verification. So things can be tested and you can validate if some future intervention will bring the expected benefits to the building. The third one is demand response. So we have a few equipment that are being part of this demand response service, where our algorithms are let's say, understanding when is the best time to switch on or switch off some according to the grid constraints or according to the energy peaks, etc. We have the fourth core service, which is the fault detection and diagnosis. So we can perform this fault detection and diagnosis in a number of different use cases. For instance, we can detect failures in smart valves. We can detect failures in air handling units or light if the light's not working properly, because we have also luminance sensors. And finally, and the last one is the predictive maintenance, where the main goal is to evaluate in real time if how some equipment is performing, and detect when would be the next maintenance needed, because it's better like to fix something or to replace something before it's too late, because if you wait some equipment to fail before you do it, you can spend much more money, and because you are going to have some your process can be like stuck, and you don't have time to do it like on the fly, let's say. And we have some additional services which will be which IBCAM is going to provide an API to allow a third-party integration. And so additional services such as healthcare management, EV charge optimization, and car sharing can be also integrated to IBCAM platform, and also others depending on the kind of application. Some of the key hardware components in IBCAM. So in the building site, we start with the automation server, which is used to connect existing and new building management system sensors and meters. And this is a gateway where like all the other sensors send information to. Secondly, we have the smart thermostat, used to optimize heat and cooling and can receive automated actions. We have the demand response panel that enables demand response services, and the smart sensors in the buildings to monitor and make predictions. They are basically indoor air quality, so they can check the temperature, the humidity, the CO2, CO, illuminance. And in the other side, we have the key cloud software components, which is the enterprise, starting with the enterprise server, which is collect all the information from the automation server that I presented before. And this information goes to ISCAM, which is responsible to store and analyze data collected from the buildings. ISCAM is also what where some of the services are deployed. So you can create rules and channels and scenarios that can be tested. And also ISCAM allows other applications and other services to collect the data from it, such as the auto calibration tool that enables predictions with accurate physical-based simulations on the cloud. Because in IBCAM, we are also using the concept of digital twins. So for each of the pilots, we have a digital twin that can get data from ISCAM and calibrate the models to have good accuracy. And as I mentioned before, there is also the API for third parties. And here's just another visualization of the hardware and software. So in the left side, we have the building with the smart sensors, the demand response device, and other hardwares that sends information to the gateway, and the gateway communicates with the enterprise services. And then the information and data goes to ISCAM that sends this like to advanced dashboards, or to the or it can be used for the digital twin to be calibrated, or to other services. And here I have just some examples of the dashboard and the information that IBCAM is going to provide to the end user. So this is energy dashboard. So, and the information will be displayed in a combination of KPI cards. So in this example, you can see the annual cost of energy, the improvements compared to the last year. You can see the total energy, electricity, and in this case, gas, like by month. And you can also have some real-time information, or information with more with a better granularity. So you can see this is hourly measurements for some of the sensors, and you can also see some of the aggregated values for instance, for some rooms in a specific building, or some specific areas in an industrial facility. And the second example is the comfort dashboard, where users can see if the temperature or if the CO2 levels are not according to the standards. So it will going to show it's going to show for the users in a friendly interface if the status of each of the rooms are like all right or not, showing the screens, these colored squares for each of the rooms. Red is that there's something that needs to be verified in that specific place. And this information and the dashboard can also show the actual values for each of the rooms, or from each of the sensors, and the humidity also in real time. And the dashboard can also be configured to display some alarms, which is very important for the building managers, especially if we are talking about industries that requires some high level of accuracy in the thresholds to be kept. So, in these alarms can show if the CC is not operating, or if the CO2 and temperature are outside the required limits, or if energy consumption in that place is higher than expected, or even if there is missing data that can mean that some equipment presented some failure. And this can be also, these dashboards can also show the information from alarms from the services. For instance, the fault detection can just send an email or show in the dashboard which equipment has presented some failure or anomaly, and also the dashboard can show what is the expected replacement date for batteries, in case you are monitoring some using the predictive maintenance of service. And this is just another representation of the dashboards. This is bringing a more general view of the whole building. In this example, we have this mock template for Hicks building, where users will be able to see each of the services, the fault detection, diagnosis, predictive maintenance, demand response, and what if scenarios. and the KPIs that are important. And in the center of the screen, you can see for instance, the number of hours out of the comfort zone, and the real data showing the temperature at that time, and also some historical information about the air temperature, relative humidity, CO2, and luminance. And you can also see you can also create the different areas for each of the rooms, each of the floors in the rooms, and you can see how each of them are performing. And the IBCAM platform can also simulate what-if scenarios. So let's say that one needs to wants to see if a new intervention, a new energy conservation measure will bring some benefit to that building or not. You can first test it using the digital twin. You can see down there in this picture, so you can test it. If you want to replace the insulation of some wall, or if you add, for instance, PV panels or a different of energy production, you can test it in these simulated models in this digital twin, and evaluate if it's going to bring the benefits that you are expecting. And if it is, and you can do this like before deploying in the real world. That is it from my side. Thank you very much. And if you have any questions, you can just put it in the chat, and you can discuss it later. Thank you very much.
Thanks, Paolo. Thanks for that. Very interesting presentation again. So I'm working on the project, so I know how good it is, and the latest results are very exciting. So yeah, thanks very much for that. Really good presentation. So next we have the SATO project, and Professor Pedro Ferreira from the University of Lisbon will discuss the SATO project. So Pedro, if you're there, can you start?
Yes, I am.
Yes, all good.
Good afternoon to everyone.
So yeah, it looks good. I can see your slides, and your audio is working. So yeah, if you wish to continue, then I'll...
All right. Thank you. So again, good afternoon to everyone. I just would like to start by thanking the invitation.
Sorry, Pedro. We can't see you. I think it's we can just see your background.
Sorry, you don't see this.
Oh no, we can see the slides, but we just can't see you speaking. I think it's something with your background, but
no, it was just the protection of my camera.
Okay.
Sorry.
No problem. Okay, you can continue now. Thank you.
All right, thank you. No, so I was just thanking the invitation for being in the event and having the chance of showcasing SATO to whoever is listening. So SATO means, the acronym means Self-Assessment Towards Optimization of Building Energy. It's a European project, as you know. So SATO is made of 16 partners across 7 European countries. We have 9 pilots that we test using more than 15 use cases. 15 was a number at the beginning of the project, but actually this evolved, and we have different additional use cases that will serve our demonstrations and our evaluations of the project. These pilots are structured, or they belong to different classes of buildings: office buildings, residential buildings, and retail stores. And we have them, the office buildings and residential buildings, we have cold and warm climates. So we have pilots in Denmark, in Italy, in Portugal, and we have also got this in Austria, another pilot. SATO answered a specific challenge in the topic that we applied for, which was the fact that most and this is in addition to the inefficiency and the inability of most buildings, as was pointed out in previous projects here, being able to be energy efficiency. Also, homeowners and building managers, they are unable to assess the real life energy performance of their buildings and the equipment and the appliances within the buildings, which is really big limitation, because without having updated and assessments connected to the real life, to the usage that occupants are making of the building, it will be difficult to improve the buildings, to prioritize where to make improvements, where to buy new equipment, which functionalities to add, or technical domains to add to the building, and so on. So what is the main objective of SATO? So the most general way of saying it is that we want to create an IT platform for automated self-assessment and optimization of buildings' energy. And this IT platform should be capable of assessing the real-life building energy performance, of course, of the building and of equipment inside the building. This is the general objective. To achieve it, our main, let's say, our main options, or our main tools, let's say, is, as you know, buildings are have a big heterogeneity of devices and systems installed that speak different languages, different data formats, different protocols, and so on. So our approach is, of course, of integration by means of semantic-based interoperability. Semantics then also have another advantage, that if we have good descriptions of all the objects and components of the building with properties very well described, we can also exploit that to provide, and this is we put a lot of emphasis and effort in our project, that we are able to do automated discovery of assessments and services within the building, so that deployment is not a big issue. So when deploying the SATO platform, if we have done well our preparation, the platform should itself realize where to do a whole building energy assessment, where to do a certain kind of appliance assessment, where to do thermal comfort assessment, according to the data and availability of all the requirements that each different, let's say, software component or part of these services require for performing. So I'm going to give a brief overview of the SATO platform. So I already spoke a bit about deployment, and let's say the configuration or the parameterization of the platform. We have two main ways of doing it: through operational interfaces, web-based interfaces, or through BIM files. And this is something that we really want to demonstrate towards the end of the project: the possibility of getting a BIM file of describing the geometry and all the zones in the building, etc. But to this BIM file, we add extra IFC layers that also tell us where sensors are located, what are the actual IDs of these sensors, where do we have HVAC systems, batteries, PV systems, all the devices that have some role in the management of energy flows within the building, or that can be used in the case of sensors to provide elaborated assessments of the energy performance. So the idea is that we can use these BIM files to input information on all this infrastructure, let's say, for energy management in the building. And this will actually create what we call a context information model. It's actually the basics of a digital twin, if you wish. And by doing so, and if the IFT is well built according to the equipment that is inside, also by configuring all the devices endpoints to send information to the right endpoints, the platform can recognize already from the data coming in which bits of data belong to which system within that building, and then start, of course, operating. So our IoT layer then is ready to receive the data, to identify where this data belongs to, and also have this context information model that allows us to have a kind of automated discovery of assessment and service, energy management service possibilities. On top of this IoT, this is what we call the SATO middleware that has the data and the context information model. We then have a layer which we call the self-assessment framework that has been already activated according to the building specific through the context information model, which has a number of KPIs and assessments that are executed with the frequency that is specified for those KPIs and those assessments, that on top of the data, they form already a layer of more elaborated knowledge about the performance of the building and of the energy systems, building systems, and in the case of residential buildings, the household appliances, air conditioners, photovoltaic systems, batteries, EV, if there is one, and so on. So this assessment framework builds a layer of different assessments of these different categories, which I will identify in a few minutes. By using this self-assessment framework, we have what we call the third layer here, the optimization services, which can use the information from the assessments and the data itself and feedback from the users, so that it can we can build a set of different services for flexibility, for thermal comfort, for instance, and other anything that has a purpose on managing the energy flow within the building and in and out from the building, I would say. So these services exploit the data, the assessment framework to make decisions and to act back upon the building. The last layer that we have, sorry, this, yes. No, yes, the right side, sorry. The last layer is about interfaces. And again, here we exploit two possibilities, the usual, let's say, approach of doing web-based interfaces, but also of using BIM tools where we can display the results of the assessments with a given time and spatial granularity that we wish. So we can look the thermal comfort in a zone or in a single room. We can project in the BIM model, in the 3D representation, the performance of different equipment when we are exploring that zone. We are using color-coded ways of presenting the devices or the different zones so that it relates to the performance of those zones, rooms, or eventually the equipment. And that's also the way for the owners or the building manager to make decisions or to interact with the systems themselves. So what kind of assessments are we considering in the self-assessment framework? I just would like to stress that assessment is the main or is the core part of the project, and it's of course the core part of the topic that we answer to in the energy program. So we have 5 categories of assessments: whole building assessments, where we can compare the performance of our building according to its, for instance, to its past behavior and see how well we are in the present. We can also see how the building performs when compared to the average building of its class. So we made an extensive survey of existing buildings and their consumptions within the literature, within lots of information sources. And we did this for different categories of buildings. And we can do this in time granularities of 1 year, 1 month, 1 week, hourly based, and we can present how is our building performing in relation to, let's say, average and other buildings' behavior. We also have building envelope assessments, occupant-driven assessments like thermal comfort, the occupancy of the building, relating occupancy then to different parts of the performance of the building, different aspects of that performance. We have another category of assessments for the building systems, the main building systems, about HVAC systems, for instance, an example of what we do. We have then a special kind of class of assessments for the residential sector on household appliances. It was one of the issues that even when we were doing the project negotiation stage, the project officer, when we were signing the contract of the project, he asked us that he wanted this project to provide at the end policy recommendations and the recommendations on how to do a real life assessment of household appliances that could complement the energy label, which is a bit static and elaborated in, let's say, controlled conditions, but in a very restricted way, let's say. On the third layer that we have, the services, we have, of course, the self-assessment service, which is like a conveyor of all the assessments that we have and that can be used even by third parties through an API. We have aggregated control services that try to take inputs from different aspects like thermal comfort, flexibility requirements, the possibility of photovoltaic production, the capacity of batteries that we have, and makes decisions on how to better manage those aspects. Of course, we have the user comfort when looking at itself or on its own. So we are making different kinds of studies on how to aggregate this control or do it individually. We have, of course, the flexibility component, and then some services towards fault diagnosis and failure detection on systems and equipment. So to wrap up, we are in our almost ending our third year of project. We are starting our demonstrations. Almost our pilots are now coming into operation, but still we are finishing some works even on some of them. The pandemics and then the crisis on semiconductors, they gave us a bit of stress, but I think we are getting there. So I would say in September, we should have all pilots able to demonstrate the assessments and services that we have been developing. And hopefully we'll have almost or a full year, because we end the project in September 2024, where we can learn some more about what the systems are doing, what our assessments and services are doing, maybe improving, but collecting lots of results on these aspects. So for the future, we want to bring our ideas to the design phase of the buildings and for also refurbishment of existing buildings. And also we want to improve, because the focus here was on functionality, assessment, and optimization. We want to really innovate in, I'm from a computer science department. We have a very good group on security and privacy. And I think we can do a very good protection of all the systems regarding or using end-to-end data protection and privacy preservation techniques. More than this, we should follow, this is already going on, certification and compliance procedures with a view to a possible commercial spin-off of the project. So thank you very much for your attention. I will be happy to answer any questions that you might have.
Thank you, Pedro. Again, a really interesting project and really interesting presentation. We look forward to seeing the next phase of the project and what's to come from SATO. So thanks very much for that. So for the last of the projects, I will invite AUTODAN to speak next. So the AUTODAN project will be represented today by Beatrice Fraga Del Cal from IES and also Selena Solari from RENA-C. So if you'd like to come turn on your camera now and then also share your slides, that would be great.
Yeah, hello everybody. I'll share the screen first. I'll introduce myself also. Can you see my screen?
I can see him now. Beatrice, if you just want to go to the presentation mode. Yeah, that's brilliant. Yeah, so I think everything's okay now. Work it well.
Okay. So hello everyone. I'm really happy to be here. Thanks to the Irish Manufacturing Research to organize this event. And also it's been nice to be listening to other projects. I particularly think we have AUTODAN has some similarities to SATO, so that was really nice to hear. So my name is Beatrice Fraga. I'm project manager at IES-RD. IES is a consultant and software company in digital twins in the built environment. And AUTODAN is one of the projects we coordinate. So AUTODAN is mainly it's a project to make use of IoT technologies that helping the self-optimization of buildings. So the full name is quite long, but I hopefully explain you throughout the presentation. AUTODAN literally stands for Deployment Augmented Intelligence Solutions using data analytics, interoperable software, architecture, and a novel self-energy assessment methodology. I'll be presenting the first part, and then Selena will present the second part, and I will let her introduce herself after. Or you prefer now, Selena, up to you.
I introduce me now, so then we can go directly on the slides. And I'm Selena Solari from RENA Consulting. I'm the dissemination leader within the AUTODAN project and coordinate the RENA activities within the project.
Thank you, Selena. So she'll explain further their activities at the end. So just a brief agenda. I'll give you an introduction of what's the context and why AUTODAN exists. Objectives, a little bit of the platform and the demo sites, and at the end, some hardware solutions that we are applying and some results till now. We've been like 2 years working in this project, so we have some results that we could share with you. So first of all, so what's the context behind that? Like we all know, like in this, I'm sure everyone knows in this room, like, and we are aware of the energy crisis, all the ambitions that we have in terms of reducing primary energy and final energy consumption. And in order to do that, one of the solutions to do that is to actually use IoT equipment that can measure and can help the buildings to be optimized and also help the users to know how to do that. And that's where AUTODAN fits in. The main objective of AUTODAN is to provide home residents with knowledge and information to reduce that consumption of energy cost. Because something that happens at the moment is like there is lack of information and automated systems in the domestic sector. So it's difficult for users to actually know how to save energy or how to improve the performance of it. And that will be achieved through energy data that we will collecting and providing possible actions to the users. I think it's important to say that in terms of augmented intelligence, there is no need. Unlike the artificial intelligence, in the augmented intelligence, we need the user. So we don't intend to make the system fully autonomous, but making the use of the human interaction with also the smartness of the equipment. So with AUTODAN, we all are safe, and robots are not fully needed. So we need both parts. That's just a summary, a map of the team. We have partners in Ireland, IES, to Dublin University, Semicon that is manufacturing the smart meters, and AUTODAN helping them to actually make it commercially viable. Oculan that provides like a demo site. Then we have University in Burgos and Cardiff in Spain. And in Italy, we have other 4 partners, RINA, Flarebit, CBSCO, that I have to say that this is a typo, it's actually R2M now. Sorry for that. Data Ecopolis that also, it is a pilot, and Arçelik in Turkey. I don't have time to go through all their activities, but it is a very complete consortium. If I have to summarize the key objectives of AUTODAN, there's 5. The first one is we have to create a smart hardware infrastructure. The second one is we have the hardware. Now we need like an interoperable software architecture, which is like it's a challenge to make it interoperable and make all components to talk. And we also need to deliver the augmented intelligence solutions. That's going to be part of the dashboards. Then we create a life self-energy assessment, and last but not least, accelerate the investment in sustainable energy companies. So that's the platform. I think that gives a good insight of what's behind AUTODAN. On one side, the left-hand side, we can see the smart hardware infrastructure that I mentioned at the beginning. All those equipment, sensors, IoT technologies will send data to iScan, our data analysis platform, that after it's collected, that data will send to the software and the energy assessment framework. On one side, the software consists of 2 main components, the digital occupancy model and the digital twin. The digital twin will take care of the optimization measures at building level, while the digital occupancy model will take care of appliances level. So one is building and the other one is equipment. And then on the other side, on the bottom side, we have the self-energy assessment framework that will need these outputs coming from both, from the digital twin and the occupancy model. This is just like an overview of the demo sites we have. We have a total of 6 demo sites, and for now we've created the physics-based model of each of them. This is like a thermal analysis that creates the baseline of all buildings before we collect the real data, calibrate those buildings, and actually become those buildings will become the digital twin. At the moment, they're just baselines and calibrated, some of them with bills, and hoping to collect real data soon to make them accurate. So I'll show you that we have one in Dublin, that domestic affordable housing. We have Palazzo Terrani in Lisone, that is a theater. We also have a foundation in Burgos, Spain, and the other three are a cooperative multifamily building in Milan, a student accommodation in Burgos also, and then a business park in Dublin. That is one of the most challenging ones because we have 13 buildings with very different usage. So that one was a difficult one to collect and to apply the AUTODAN platform. In terms of the hardware solutions, we do have the energy monitoring, that's electricity meter I mentioned before, Semicon is manufacturing. Then we have smart plugs and smart appliances. The smart plugs are actually essential for the occupancy model I was referring before. And then in terms of we have the environmental monitoring, so multi-sensors that collect humidity and CO2. And also we have these energy hubs that help to all the communication of devices. That's an overall of the hardware solutions. And now I will go to the first result. I think it can be interesting for you, and that is the digital occupancy model. I've shown you before that the software will have the digital twin at building level that at the moment is only like baseline energy models. And then we have the digital occupancy model. This is responsible, and what does it do? So this model helps the residential users to schedule the equipment for the following day, depending on the energy prices. So what I show in this diagram is the three components that the team has developed, and that describes a little bit how it works, because there are two paths to achieve that. One path is load desegregation, using the load desegregation component. There is where we don't have, in the case that we don't have smart plugs and we have the full load of the building, we have this, we have to develop this optimization component. Then another option is like we have the smart plugs, so then that load desegregation is not needed. Then we have the clustering. The clustering is a process to obtain the most frequent pattern, and that has to happen regardless it comes from a load desegregation path or if it comes directly from smart plugs. And all that can actually send all the algorithms are methods to the next demand side management optimization. This is a general overview. There is a complex process behind, and the team has developed and put a lot of effort. And the last result I'm going to show is the dashboards. The dashboards where we will be showing the augmented intelligence solutions of AUTODAN. The dashboards, they require there's a lot of process behind it, is because here is where stakeholders, developers, and UX design put their ideas together to deliver this, and requires a lot of communication. It's not only like a nice design. That something I've learned is that requires like a lot of communication to make sure that actually the user gets what they are expecting. So we don't provide solutions that the user doesn't need. It's very important to keep the user all the time at the core of the design. This is just like an overall displays of one of the tags where you can see the energy consumption, the tracking of your energy savings, and the notifications on the right. I'm not going to go further. I don't have time. So I'm going to give the floor to Selena, that's going to explain more the self-assessment framework. Thank you very much. I'm happy to hear your questions after that.
Thank you, Beatrice. Okay. Next slide, please. Okay. So another AUTODAN result is the self-energy assessment framework. It aims to generate an assessment as complete as possible of the actual energy performance of the building, taking in consideration the monitoring of the energy consumption from different levels, so both at the building envelope level, but also at the appliances system level, incorporating also some European regulation on energy. This framework will be able, through the dashboard showed by Beatrice before, to provide to the building user some useful information, such as the actual operation of the building, or the actual monitored consumers, or also some advice on how improve energy efficiency or improve user habits. It also aims to give some suggestion in order to replace all the appliances to the user and improve the overall energy efficiency of the building. Next, please. So to reach this purpose, 4 different levels has been defined, and for each of these levels, a set of KPI has been proposed in order to help the user to make a comparison between their actual energy performance of the building and some data from literature. So we have a building level, which include all the energy consumption referred to the entire building and apartment, and this level can give a good awareness about the general energy performance of the building through some specific indicator that can show the difference, for example, of the energy consumption calculated for the certification, or some measurement came from sensor, the previous, thank you, so from some sensor in real time. Then we have also an appliance level that take in consideration all the data, the information referred to the device and appliances inside the building. We have also a financial level that try to express the energy saving in a more concrete way, so in a monetary terms, and so through some indicators try to give a financial impact of some good energy saving solutions. And finally, we have also an environmental level that is referring to the CO2 emission and also tree planting, that through some specific indicators try to express the environmental impact of some energy good choice of the users. Next, please. Thank you. So as this result, this assessment framework, as I mentioned before, try to be as complete as possible. So it is a holistic assessment that would like to try in consideration not as usual the building envelope, but also different levels such as the building automation level, demand response level, and appliances level. And the objective is to give to the user the feedback in the more easy and simple way, so through some graphs and graphical representation, in order to give some indication of in real time of the performance of the building, and give information on the weight of the different services in terms of consumption. And in this way, the user can act to improve energy management system, participating also through some demand response strategies. Next, please. So let's conclude with some project channels where we can keep in touch. In particular, there is the AUTODAN project website where you can find some more details, more information about the AUTODAN project, also some material such as the public deliverables submitted and more detailed information on the demo case. And we also have the LinkedIn, the Twitter page where you can you can keep update on the progress of the project on the news. Next, please. Thank you. And finally, we will also release the project newsletter. So if you would like to have a periodic update about the project, you can subscribe the newsletter in the project website and receive some update every 3 months. Next, please. Okay, so I think it's all from the project, the AUTODAN project website, the AUTODAN project side. I don't know if Beatrice would add something, and I thank you all very much for the attention.
So thanks very much, Selena and Patrice. Very enjoyable presentations. Again, the AUTODAN project, it's very interesting, and there's a lot to look out for. And as you mentioned, make sure people visiting the webinar today go onto the AUTODAN channels to look at the latest progress from the project. So finally, we're going to finish up with some polls just to gather some feedback and some engagement from the audience. So now I'll hand over to Lorenzo Sibioni, who's involved in the COLLECTIEF project and a member of the R2M Solutions company. So Lorenzo, take it away.
Hello, everyone. Thank you, Mark, for presenting me. So I want to thank all the panelists for very interesting presentations. As you know, most of these projects are related to advanced BMS systems. So here I want to present you a short survey that deals with the diffusion and replication of these systems within the market. So you can either scan the QR code here to take part to the survey. There are just 3 short questions with a multiple choice. Actually, they are ranking questions. So I will just give you 1 minute to scan the QR code, and then I will read the questions. So starting with the first one, from your point of view, what are the most significant drivers that could convince a potential client to invest in a BMS platform, advanced BMS platform? So just to show you the possible answers, these are the possible drivers that you can choose, and you have to rank them from the first one, which is the most important for you, to the 7th one, which is the least important for you. So we have energy and economic savings, increase of productivity of employees, revenues from flexibility services, diagnosis of building energy usage, building value increase with possible certifications, interoperability of the HVAC equipment, and building carbon footprint reduction. Then going to the next one, you can start answering to the poll if you want, while I read the questions. The second one is, okay. From your point of view, what are the main barriers to overcome for the replication of advanced BMS platforms into the residential building market? The options are uncertainty in the energy economic savings expected, high initial investments, the communication of benefits to tenants, difficulties related to installation works, and incompatibility with legacy equipment. Of course, all the spectators and also all the panelists are invited to participate. So all of your opinions are very important for us. And then I will read to you the last question. So from your point of view, what are the main barriers to overcome for the replication of advanced BMS platforms into the ESCO market for commercial or industrial buildings? Options are uncertainty in the energy economic savings expected. Okay, people are starting to answer, that's good. Difficulties in the implementation of performance and the measuring verification procedures, competition with standard energy efficiency measures and the renewable installation, and deficiency of suitable local technology providers and skilled personnel. I will maybe wait just 1 more minute to let people time to answer, and then we can see together all the results. Okay, I can start reading the results. Maybe further results will come later. So for the first question, in your opinion, energy and economic savings for sure are the most important driver for BMS, advanced BMS platform diffusion. And the least important for you is the interoperability with HVAC equipment. As for the second question, the main barrier to overcome for the replication of advanced BMS platforms is the difficulties related to installation works. I agree on that. And the least important for you is the uncertainty in the savings that one could expect. And as for the last question, the most important barrier for the diffusion into the ESCO market is the incompatibility with the existing devices due to proprietary communication protocols. And the least important for you is the uncertainty in energy economic savings expected. So that's very interesting. I thank you all for your answers, and I leave the floor to Mark.
Thanks, Lorenzo. Thanks for that. Yeah, so I think we come towards the end of the webinar. Just a couple of minutes left, so I think we're okay to finish on that. Thanks very much to all our speakers today, and thanks to those who attended. If you have any questions related to the projects, make sure to check out the project websites and social media channels where you'll be able to find a contact person. I hope you all enjoyed it, and we hope to see you again at another event. As mentioned at the beginning of the webinar, do make sure to check out the EU Sustainable Energy Week website just to get an idea of the events that are happening within your area and the events that have taken place within the last couple of weeks. So that's it for now. Thanks very much, and we'll see you all again soon.
Thank you. Bye-bye.
Yep.
See you soon.
Thank you. Bye.
Thank you. Bye-bye. Take care.
Thank you. Bye-bye.
Thank you. Bye.
Okay.